Hi everyone, welcome to the second lesson for topic 4.1 time series analysis. So for today's lesson, we are moving into the second subtopic, which will be looking at how to analyze time series data. Okay, so today there are only one learning outcome that we need to achieve at the end of the lesson, which is how to smooth time series data by using a simple moving average. Okay, so this is the keyword that I want you to remember. So which means after today's lesson, you will be able to do simple moving average for time series data. So for the part where we use spreadsheet to implement this process, we'll be looking at it in the next lesson. Alright, so let's start with some recap on what we have learned during the past lesson. Alright, in the previous lesson, we talked about the relationship between topic 3.1 bivariate data analysis and also topic 4.1 time series data. And from there, we know that time series data is actually one type of bivariate data. So which data with two variables. And then the explanatory variable in this set of data, which means the explanatory variable in time series data is always the time, because time is something that we can't change, right? So we use time to explain the difference in the response variable for which the variable that you want to investigate. Okay, so for example, when we say that you want to find out the rainfall throughout the year, then which means that the time may be for each of the month, then response variable will be the rainfall. Okay, so we talk about the different characteristic when we try to look at the time series plot, right? We talk about long-term trend, we talk about different variation, either that's irregular one or that's a seasonal one. So I also emphasize on the part of seasonal variation because that's the type of data that we are going to deal in most of the time under this topic. Okay, so we say that the data has a seasonal variation when there's a similar pattern of peaks, which mean the high points, and troughs, the low points at corresponding months or quarters of the successive years. Okay, so let's try to do some revision on how to find out the cycle or how many points made up a pattern. Okay, so you can always use the peaks or you can also use the troughs to help you to find out how many points in one cycle. So for example, in this case, if we are using the peaks, then maybe you can try to circle it. Okay, for example, I can see that the high point is all here, right? And then here and also here. So which means that I can roughly estimate that the peak will have like the last point at the peak part. So which means 1, 2, 3, 4, and then 1, 2, 3, 4, 1, 2, 3, 4. So which means in this case, I know that this set of data is having a 4-point cycle. Okay, so this is very important because it's going to be decide how many points that you need to use when we talk about smoothing the data later. Okay, so in this case, the same thing, maybe we can try to use the troughs here. So you can see the lowest point is basically here and here. So maybe for this set of data, the data points that we have is quite limited. I mean, it's a less one compared to this one, but you can still try to look at the pattern. So which means you can roughly know that from the highest point to the lowest point, then from here to here, you can see that's 1, 2, 3. So which means you should know that 1, 2, 3 made up the other one. So this is the lowest point before as well. So 1, 2, 3. So this is the lowest point. So this set of data is having a 3-point cycle. Okay, so this is just a quick revision on how you identify the point, how many points in a cycle. Okay, we also can call this point as season. Alright, then after that, at the end of the lesson 1, I talk about the relationship between bivariate data and also time series data, and basically it covers everything that we are going to learn under this topic. So we know that in majority of the situation of time series data, we are dealing with seasonal data. So which means that it's a kind of data with seasonal variation. Okay, so because we are having a seasonal data, so that's why the trend that we are able to see, right? I mean, although you can still see that there's a long-term trend, but then if let's say you want to do prediction, you will have a kind of difficulty because there is a seasonal effect involved in this time series data. So that's why what do we need to do to make the underlying trend much more apparent is that we try to do smoothing the data. Okay, so from the seasonal data, we want to identify what is the underlying trend. So we want to make this trend become much clearer one instead of like this one. Okay, then after we find out the trend, after we smooth out the data, then we find out linear regression and so on. Then the same thing with bivariate data analysis, and we are going to make prediction from the regression equation as well. Okay, so today's lesson will be much more on the technical part, which means it's like a practical one rather than a theoretical one. Basically, it's a lot of calculation. Okay, so smoothing time series data is a technique that we use to level up the fluctuation. So which means that we try to smooth out the data so that it is like much more flattened. Okay, so that we can make the underlying trend much more apparent. Okay, or it's like much more clearer lah, in a simpler words. All right, so in a previous session I have touched a bit for this one as well. So there are two techniques that we are going to learn for this topic. The two techniques that we use to smooth the time series data. The first one is called as moving average, and this is what we are going to learn for this week lesson. So today's lesson and Thursday lesson, we are going to talk about moving average. Then for the next week, we are going to talk about the second part, which we use this seasonalization to smooth the time series data. Okay, so moving average will be an easier one, but in terms of effectiveness and in terms of you are able to look at it in a much more in a much more qualitative way, than the seasonalization is the more effective one. Okay, so we'll start from the easier one, that after you can understand the idea, then we'll move on to the second one in next week. All right, so let's start with our lesson today, which we talk about what is that meant by moving average and how to do that. All right, let's start with a simple definition here. So in the time series data, a simple moving average is a method that we use to smooth the time series data, whereby each of the observation, which means each of the raw data now, is replaced by a simple average of the original observation and also the near neighbors, depending on how many point of moving average that we are doing. Okay, so this process helps us to reduce the seasonal effect of the time series, and then from there, it will help us to make the underlying trend much more apparent. It will make the trend easier to see lah, basically. So there are two types of moving average that we are going to look at today. So the first one is odd point moving average. So for this one, it will be much more easier, that this is the first one that we are going to do as well. Then after that, for the second part, which means by using the second example, we are going to look at the second one, which is the even point moving average. So because of its even point, then later when we want to find out the average, you realize that there's a small issue that we need to fix. So that's why for even point moving average, you will have an extra steps to solve compared to the odd point moving average. Okay, so even point moving average is also called as centered moving average. Alright, so just to let you know that by default, moving average includes these two. So which means that no matter you are doing a odd point moving average or you are doing a centered moving average, it's basically means moving average. So which means that even you are doing like a 4-point moving average, you suppose, in a much more specific words, you should use 4-point centered moving average, right? But if let's say we are talking about 4-point moving average, is by default that you should know that you should be doing centered moving average, because 4-point is like an even point. Okay, so no worries about that. Later we are going to look at it. But now let's try to look at the first one to understand what is that meant by moving average first, and we'll be using an example of odd point. Alright, so let's look at example 1. Alright, so this is the exact same example that we used to construct a time series plot in the previous lesson. Okay, so during 2014, the owners of a particular tourist attraction decided to use the data regarding to the number of visitors the center has had in a recent year, so that you want to identify the trends and to indicate the visitor figures for the future. Alright, so the owner have the access of 4 monthly visitor totals for 2011, 12, and 13, and also the first 4 months for 2014. So identify the seasonal variation and suggest the most appropriate moving average to use to smooth the data. Okay, so by looking at this set of data, so this is the graph that we have drawn in a past lesson. So that's why you doesn't really need to redraw that. I have put inside your handout. Okay, so by looking at this, then we can try to you can try to look at the peak or you can try to look at the trough, then it will give you the same answer of how many points in one cycle. Okay, so let's try to look at, if let's say I'm trying to use like a trough, then which means that you can see these are all the lowest point, right? Then you'll be realized that 1, 2, 3 made up one cycle, 1, 2, 3 another cycle, 1, 2, 3 another one cycle. So it's a 3-point cycle. Alright, so no worry if you are using the highest point, you will get the exactly same thing. So for example, if let's say instead of the lowest point, you choose to use the peak, so you have these two, okay? Then you will realize that this is the highest point as well. So you can get 1, 2, 3, 1, 2, 3 also, then 1, 2, 3, this is supposed to be a higher point. So you see, no matter which point that you are using, then you can see that all these points recurs at the consistent timeline. So that's why in this case, this data has a 3-point cycle. Okay, so so the question one is to identify the seasonal variation, right? So you can just write down it is having a 3-point cycle. So if let's say it's a 3-point cycle, which means that the moving average that we are going to use to smooth the data, it's supposed to be a 3-point moving average. Okay, so because we are using 3-point moving average, so you can see that 3 points, so 3 is an odd number. So that's why this moving average is known as a odd point moving average. Alright, I hope that you get what I mean. So which mean, there's no 1 point lah. So 3 point, 5 point, 7 point, 9 point, 11 point. So all these are called as odd point moving average. Then we are going to use the same method. Then later we are going to look at like 2 point, 4 point, 6 point, 8 point, which we are going to do even point moving average. Alright. Okay, so by looking at this set of data, now we need to carry out 3-point moving average to help us to smooth the data. Okay, so now let's try to do that. So write down here 3-point moving average. Alright, so how can we do that exactly? It's actually very simple. So what we need to do is to find out the moving average. So how to do that? 3 point. So which means that 1, 2, 3, then we can find out what is the centered point and what is the average of these 3 points. So which means that we have 45, 26, and 34. So by using our calculator, then we can try to find out 45 plus 26 plus 34 and then divide by 3. Okay, so we find out the average of these 3 numbers. Then after that, we'll write down in the middle. So which means that 45. So for the first three row, I will want you to write down the working, because this is why I try to make the row like slightly bigger space compared to the other one. So for the other one, after you understand this is like a repetitive process, then it doesn't really need to write. So for the first three, then we try to write down. So when you try to look at the handout in future, then you know how do you get all this number, right? Okay, so just now it's 35, so which means it's supposed to be 105 divided by 3, and you can get 35. Alright, so you are using these 3 numbers, so that's why you are writing at the middle of the first 3 points. Alright, so yeah, this is the middle, right? Okay, so then you continue to look at the second row. So which means that now what we need to do is look at the next 3 numbers. So it's going to be, I'll use the other color. So it's going to be these 3. Okay, so for these 3, the middle is here. So that's why the number that we are going to use, it will be 26 plus 34 plus 52 and then divide by 3. Alright, so same thing, we try to use our calculator. So 26 plus 34, 26 plus 34 plus 52, and that gives us 112. So when we use 112 divided by 3, and we'll be able to get a number of 37.3. Okay, so let's try to just use one decimal point here. So 37.3. Okay, I guess it's quite direct. So the same thing, we are going to continue for the next one. So 1, 2, so you have used 1, 2, 3 and 1, 2, 3, right? So we will move on for the next three. So same thing, it will be from this number up to this number. Wait, let me try to change the color. Yeah, so that will be this number up to this number. So same thing here is going to be 34 plus 52 and then plus 37 and then divide by 3. Okay, so same thing, we try to use our calculator to help us to do that. So 34, 52, and then 37. All right, so we can get 1, 2, 3. So 1, 2, 3 divide by 3. Okay, and you can get a whole number 3, 4, 12, and then 3, 1, 3. All right, so this is the number that we can get. So you move on, then you try to get all the value. Okay, can you try to do that? So I'll try to fast forward the process that I use calculator to get all this. So you can try to just let the video play around, then after that you use your calculator to get the rest of the number. So you might don't need to write down the working anymore. If let's say you think that you want to write for everything, then feel free to do so. If you already think that you know how to do that, then you just write down your answer. Can you do that? All right, so let's use our calculator to help us to do that. All right, so I hope that you are able to get all this value and you realize that you can't continue here because this will be the last number that you get from 3-point moving average because there's no other value after 69, right? So that's why you can't do anything. So that's why you have like a blank cell here and also a blank row here. Okay, so that's basically about 3-point moving average. Alright, so after you have carried out this 3-point moving average, right, then you will realize that the value that you have is going to give you a much more clearer trend. So you can see that from 35 to 37.3 to 41 to 43.7 and so on, you will see that all this value is actually increasing. So that's why we know that this set of time series data is having an increasing trend in the long term. Okay, so instead of by looking at this fluctuation, then after we carry out moving average, it gives us a much more clearer trend. Okay, so let's try to plot all these points that we get after moving average into the graph. Then you'll be able to see that actually you get a much more flattened line rather than this one. Okay, so let's try to plot that in. So it means now for this value for May to August, we are going to plot at 35. So which means 35 is roughly here. Okay, then after that, the third one, we are going to have 37.3. So 37, 38 is here, 37.3 is roughly here. Okay, then we can move on to the next one. We have 41. So 41 is in the middle. Okay, then we move on. 43.7. 42, 43.7 will be quite near to 44. Okay, and then 47.6. 47.6. So point that's near to 48. Then 49, it would be in the middle. Okay, 41.7 near to 42. Alright, and our last point here, 43.3. So 42, 43.3, slightly above. Okay, so this is the point that we get. So same thing, we try to connect them using straight line. Okay, So what can you realize for this new time series plot when you try to compare to the original one, that you can see that obviously this line is a much more flattened one. It is less jagged compared to the previous one that we have that is like fluctuated. I mean, at a higher range that's like up, down, and so on. But this one, you can roughly see there's a trend of increasing. And if you try to compare to a linear regression model, it's actually much more similar. It's like a straight line rather than a fluctuation that happened previously. So this is what is that meant by smoothing the data. Okay, so I hope that you get the idea of why we are doing this and then how to do this by doing moving average. So we'll be looking at two more simple illustration. What if we are dealing with like 5 point and 7 point before we move on to even number moving average. Alright, so if you are dealing with a 5 point or 7 point, which is a odd point moving average as well, so which means the approach, the method that you are going to do is exactly the same. So the only difference is just that what is the number that you are going to start. So which means that if you are starting with a 5 point moving average, which means that in the time series data, you are having a 5 pattern cycle, or you are having a 5 point cycle, then which means that you are going to do a 5 point moving average. So when you are doing that, then which means that you need to find out the first 5 point, and then where is the middle, then that should be where you start. So which means that I'm writing down A, B, C, D, E so that you can just understand the illustration without needing to actually really calculate it. So 1, 2 data 1, 2, 3, 4, 5, which means that A, B, C, D, E is the first 5 data point. So which means that the middle will be at C here. So which means this is where you need to first start the 5 point moving average. So which means you will be writing down the value of A plus B plus C plus D plus E, then divide by 5 over here. Okay, and the same thing when you move on, then which means that it will be from B until F. Okay, then the center will be at D, correct? So that's why you are writing down at D, and which means that you are trying to add up B plus C plus D plus E plus F and then divide by 5. And you will kind of do the same thing until you get the last point, which is going to be here. 1, 2, 3, 4, 5. So which means the last point will be here. Alright, so here it should be D plus E plus F plus G plus H and then divide by 5. And for the first two and the last two is going to be like not applicable. Okay, so same thing if you are doing, oops, I'm sorry, there's a typo here. I'll try to change it in your handout, no worries about that. So this is 7 point. Okay, so which means in this case the same thing, then we are going to do a 7 point moving average. So this thing might be happen if let's say you are doing a time series that you are having like a cycle is like a week. So that's why from Monday until Sunday, right? So that's like one cycle, then you continue the other cycle. So that's why you will be having like a 7 point moving average. Then you are going to do the same thing also. 1, 2, 3, 4, 5, 6, 7. And the middle is actually at the 4th point here. So A, B, C, D, E, F, G. So this is like the 7 point and you are going to put it here. So A plus B plus C plus D plus E, F, and also G. Okay, and then divide by 7. And then you are going to do the same thing in this case because that's like limited number that's given. So that's why you only have like 2 points here, which is here and also here. Okay, so normally in this case, which means that you will have like much more data rather than this. This is like just an illustration, so you can understand that every time you'll be doing the same thing, but it's just that depending on how many point of moving average that you want to do. Okay, so for this one, sorry, you should start from B. So in this case, it will be B plus C plus D, E, F, G, H. Okay, and then divide by 7. Alright, so that's basically the part about odd point moving average. So now we'll be looking at the second part, which is the even point moving average. Alright, so example 2, to monitor the planned eradication of a disease in cattle, so all vets are required to notify the government of any cattle diagnosed as having the disease. Okay, so you have this set of data that was total for every 3 months or a quarter of a year. So which means that from January until March, then you have the first quarter, then from April until June, you have the second quarter, and so on. Okay, so each 3 months give you a quarter, then which means in a year you are going to have 4 quarters, and these are the value that you have. Okay, so which means that the first thing that we need to do is to find out the cycle first, right? Although in this question you can roughly guess that because it's going to have like 4 quarter in a year, so that's why you are going to do a 4 point moving average. But before that, let's try to use our calculator to help us to construct a time series plot, and from there let's try to see whether there's a pattern or not in terms of like the seasonal variation. Okay, I hope that you still remember how to do that. So add list and spreadsheet. Okay, so remember your calculator doesn't recognize like first quarter, second quarter, third quarter. It only recognize numbers. So that's why we are going to just put it as like the first data point, second, third, fourth, fifth, sixth, seven, and so on. Okay, so we are going to put in the data. So which means the first one is going to be our time, right? So you can just put T. Okay, then the second one, we are going to put in the number of the cattle. So we just put C lah. Alright, so let's key in the number. So we have 1. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So sorry, 4, 3, 12. So that's 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, then after that for the cattle, let's try to key in all the value that we have here. So 60, 67, 47, 38. All right, then for the following year, 52, 53, 43, 28. I hope that when you try to key in the numbers, you should realize that there's a pattern. So which means that for the first quarter, you can see there's like increment, then increase, decrease, decrease, then increase, increase, decrease, decrease, increase, increase, decrease, decrease, then increase, increase. So that's why you'll realize that actually that's like 4 point in one cycle. Okay, but anyway, let's continue that. So 42, 46, 34, 23, 28, and lastly 32. Okay, so let's construct a scatter plot, then we try to observe it from the graph. Alright, so make sure that you have put in your variable before you add in your new page. Okay, so control, add a new page, and then add data and statistic. So for your y-axis, it's always going to be your time. So in this case, it's our t. Then after that, we have the variable here, which is the number of cattle. So that's why we have c. Okay, so by looking at this same thing, so you'll realize that it's actually pretty hard if you try to observe it without any line. So let's try to add in the line. So menu, either you want to go to plot type and then XY line plot, or the other alternative, menu, then plot properties, then after that, connect data points. Okay, so both works. Alright, then just enter, then you'll be able to see this line. So same thing, we can try to look at the lowest point. I think the lowest point here is much more obvious compared to the highest point, because you can see there's like 2 here, then 1 here. It seems like a little bit awkward. So that's why the easiest one is to find the lowest point in this case. Then this is 1, this is another 1, and this is 1. Then you will realize that between the point here is actually 1, 2, 3, 4. So that's why you know that there should be 1, 2, 3, 4, one cycle. 1, 2, 3, 4, lowest point, one cycle. 1, 2, 3, 4, lowest point, one cycle. So that's why this data give you a 4-point pattern as well. So that's why it's a 4-point cycle. So this is why we are doing 4-point moving average. Okay, so I hope that you can get the idea. So from here, let's go back to the question here. So if let's say we are going to carry out a 4-point moving average, I'm not sure do you realize that there's some issue over here. So it's that when you try to look at it, right? So in terms of if let's say you are having an odd number of points, for example, the previous one, if let's say you are having a 3-point moving average, then your center is supposed to be at the second point. Am I right? Then after that, if let's say you are dealing with a 5-point moving average, then you know that the center will be at the third data point. If let's say you are dealing with a 7-point data, then which means that your center is going to be at the fourth point. But then if let's say you are dealing with a even number of points, for example here, a 4-point moving average, then where should be the center of your data? Then it will be here. Am I right? So no matter which 4-point that you are looking at, right, then definitely your center point is going to be at between the column rather than at one direct column. So when we are using a 4-point moving average, you realize that the figure does not fall under a column but falls between the column. So which means that you can see that if let's say we want to find out the center and we want to write down the number for the 4-point moving average, then it will be in the middle of the the second row and the third row, which is like the 2.5 row. But then you'll realize that we can't actually invent a time like this that we tell us that there's like second and half quarter. You get what I mean? Because this is like the data that you get like in second quarter, in third quarter, this is how data is collected. So we can't actually simply add in something like 2.5 quarter. So this is the issue that we need to find out. Then you'll realize that if let's say we have all the data falls between the column, then which means that there will be a misalignment of the data and the measure of the data. So imagine if let's say we are going to plot that onto our scatter plot, right, then that will be a problem where how do we actually plot in somewhere like 3.5 quarter, 2.5 quarter, and so on. So you will foresee that this issue will not just happen when we have a 4-point moving average, but in all the situation that we are having an even number, because that's the situation that we are not going to have any exact column for the figure, but all the data that we find after moving average is going to be forced between the column. Okay, so now what do we need to do is we need to carry out this special thing which is called as centered moving average. So which means that in all this situation we need to carry out an extra step by taking a 2-point moving average of the already smooth data so that they line up with the original value, and this process is known as centering. So this is why the even point moving average is also called as centered moving average. So you must remember this word. This is very important. Okay, but like what I said, remember, no matter you are doing centered moving average or no matter you are doing like the non-centered one, they are all falls under moving average. But you just know that if let's say you are having an even point, then you should be doing centered moving average. If let's say you are having an odd number one, then which means that you are just doing the normal moving average. Okay, so let's try to look at how do we do that. Alright, so our first step is going to be exactly the same. So the only difference is that instead of like having each row filled by the data, we are now having like an empty row between every row of our data. So that's why you can try to put your data in between the row that you are going to have. So that's why the first thing that we need to do the same thing, we just carry out the normal moving average first. So which means that 1, 2, 3, 4, the 4 data here is going to be used to find out our first average here, and the center will be between the second quarter and the third quarter, which is here. So that's why, how can we do that? So 60 plus 67 plus 47 plus 38, and then divide by 4. Okay, so let's use our calculator to help us to do that. So we have 60 plus 67 plus 47 plus 38. Okay, so after we get all this value, then same thing equal to, then divide by 4. So we have 4 point here. So we can get our first value, first average here, which is 53. So same thing, we move on for the next 4. So which means that now we'll be using 1, 2, and then 3, 4. Okay, so the middle here will be in between third quarter and also the fourth quarter. So the 4 number that we are going to use is going to be 67, 47, 38, and also for 55, 52. So divide by 4. Okay, so now let's try to carry out the calculation also. Alright, so 67, 47, 38, and 52. So divide by 4. Okay, so we have the answer of 51. So I hope that you understand how everything works now. So I'm going to fast forward my calculation here. So if let's say you are still not sure, then you can try to, look at it in a slower way, that you can try to look at what I try to type in the calculator. If let's say you already know how to do that, then you just keep the video playing. Then after that, you just write down the answer for every of yourself here. Okay. So make sure you check all the values here. So this should be the last number that you get, because this is the last four number and this is supposed to be your last 4-point average. Okay, so because there's no number after 32, so that's why you can't proceed for the next two row anymore. Okay, so after we get the number, then you realize that there's some misalignment of the numbers that we have after we do a moving average according to the measure of the time that we have here. So this is like in the middle of some way. So what we need to do is we need to carry out one more step, is by doing a 2-point moving average for the smooth data. Okay, so how do we do that? Is basically finding the average of the average. So which means that we now need to find out the center point of the moving average. Then after that, we can try to align it back to the measure of time. So which means that for the first value is going to be like this. So these two values plus together give you the first centered 4-point moving average. So 53 plus 51, and then divide by 2. So 52. So you can see that it goes back to the place where your third quarter is. Okay, so that's why we'll move on for the next one. Then you'll be looking at 2-point again. So you are writing down in the middle of these 2-point, which align to the fourth quarter here. So 51 plus 47.5, and then divide by 2. Okay, so after you get this, then the same thing equal to, and we are going to get a number of 49.25, I guess. Let's try to check it again, sorry for that. Okay, so we have 51 plus 47.5. So the whole thing here, divide by 2. Okay, yeah, so that is 49.25. Okay, so let's continue for the rest. So we have 47.5 and 46.5. So these two value plus together and then divide by 2. Okay, so we have 47 here. So let's try to use the same approach to find out all the other answer. So 46.5 and 44. So try to find out the centered moving average here. Then we are able to get 55.25. Okay, then the next two. Right, so this one, let's use our calculator for that. So we have 44 plus 41.5. Okay, and that gives us 42.75. Alright, then we move on. Can find out the others as well. So 41.5 plus 39.75. Okay, and this is 40.625. So next one, 39.75 plus 37.5, 38.625. Okay, so move on for the next one. 36.25. Okay, plus 37.5, and we can get 36.875. So let's move on. All right, then for this is going to be 34.5. Okay, then the next one, 7575. So this is 4331. Yeah, sorry, let's check. 32.75 plus okay, and yeah, you are getting 31. All right, so this is the number that we get from 4-point standard moving average. So remember, for every even number, then this is what you need to do. So which means that there will be like two stage of moving average lah. So one is doing the normal one, then you'll realize that there will be like misalignment. Then what do we need to do next is by doing centering. Okay, so now let's try to put this in our calculator and see what happened after we actually carry out the centered 4-point moving average. Okay, so let me just try to do this. All right, so this is the number that we get. So after we carry out the centered 4-point moving average, so let me just try to use CMA. Okay, then then I'll be able to get starting from the third value here, 52. 49.25. You'll realize that for the cell that you leave it blank, right, the calculator will straight away dash it for you, so no worries about that. So for the coming lesson on Thursday, I'm going to teach you another formula of doing this centered moving average, and also how to use calculator to straight away help us to do all this calculation without pressing it one by one. Okay, so for today's lesson, because I want you to understand what you are actually doing, so that's why I hope that you can try to answer all the question manually first. Then after that, after you understand what you are actually doing, then only we move on to use calculator to help us to do everything. Okay, so all right, so 38.625, 36.875, 34.5, and then 31. Okay, so you will see that this is like the empty one for the next two cells. All right, so now this is the original graph that we have, right? Sorry for that. Okay, so this is the original graph that we have. So now we want to continue, we want to compare what happened after we carry out the centered moving average. So what we can do is we can add in another variable. So how do we do that? Go to menu. Okay, so make sure that you have assigned a variable for your data for centered moving average as well. You can put in any value here, it doesn't matter. Okay, so you can just control, then right, then go back to your graph. Okay, so after you get this, then menu. So what do we need to do is add in another variable. So plot properties, then you can see there's add y variable. So you just press enter. Okay, then after that, you'll be able to see that your screen will show it here. So now we want to add in another variable, which is the centered moving average, right? Then just click on it. Then you'll be able to see this. Yeah. So which means that the blue color one is the C, so which means it's the original data, your raw data before you carry out the smoothing. So that's why you can see there's like fluctuation, that this is how we realize that's like 4 pattern cycle, right? Then after that, the yellow color one, the value that we got after we carry out the 4-point centered moving average. Then you can see that when you try to compare to these two time series plot, basically this give you a much more flattened line. Okay, so that's why this give you a clearer trend that is a long-term decreasing trend, and it is more similar to a linear regression model compared to the previous one. Okay, So this is the end of this lesson. So I hope that by this time you'll be able to know how to do moving average, no matter it's in odd point or it's in even point. Then the second thing is you understand why are you doing this moving average, so that you can get a set of data which reduce or with a reduced seasonal effect. Then from there, we are going to find out linear regression. Then we can try to do a much more accurate prediction. All right, so that's basically the part. So yeah, I'll see you tomorrow during the consultation hour if let's say you got any questions. So if you have anything that you want to ask me personally, feel free to do so. So make sure you spend some time to do your homework and to understand everything by doing some manual calculation. And in the next session, we are going to see how are we going to use this TI Inspire to carry out this whole bunch of calculation by just using the function in this calculator, and also the other formula for us to carry out centered moving average. All right, so that's basically for this lesson. Okay, thanks for watching. I'll see you tomorrow.